Yes, start recording. All right, so let's consider, we're going to title these notes ITP 3, is its Introduction to Physics 3, and we are doing vector addition. Just kind of be mindful, I am recording these notes so that for all to see, so might want to keep your comments a little on the lower side. Yeah. All right, so let's kind of consider, we know what a vector is, okay? A vector is usually shown as an arrow. It has a size, it has a direction, okay? I'm already going too fast. Okay, I will slow down. Okay. All right, but I mean, we have not as a class considered addition, but give me a thumbs up if you feel like you're good at addition. Okay, now keep the thumb up or change your thumb. Are you good at addition with negative numbers? Show me that. Okay, so we have a little change in our numbers there. But addition, you've been doing since first grade, and you don't have to write this part, but we're putting together two or more things. Okay? That does kind of seem like a Mr. Obvious concept, but I want to make sure and be super clear so that we don't have any gaps in what we know about this. All right, so let's consider this one. I have two vectors. They both have a magnitude of 5. So if I draw my vectors in my notebook, I'm going to have this vector 5, and then an equal vector. So I want it to be about the same length, and I'm going to say 5. Now, when you were in first grade, they taught you like 5 plus 5 equals 10, right? So we're going to have 10. Okay, that we already know, but let's kind of digest a couple parts of this. Okay, notice I have my resultant vector is twice as long. So we added the size of the vectors together. Okay, so we're going to go ahead and label that. We're going to label that the resultant, right? So this right here. So when they ask you what is the resultant magnitude, then they're asking you what is the number that is on the vector. So 10 equals the resultant magnitude. Resultant. So remember that vocab word we had the other day? Resultant means when you add together two vectors. So 10, when I have the arrow with it, so I'm saying 10 to the right is the resultant. The resultant magnitude is just the number. Okay. Give me a thumbs up if that makes sense. Yep. Okay, good. So, all right, we have two things. We put them together. We get something bigger. Let's look at the next example. There's always more. All right, so if I have a 5 to the right plus a 5 to the left, what do we notice about that second 5? It is negative. Why is it negative? Because it's going backwards. Okay, so like one thing we want to point out, the magnitude of a vector is always positive because it is a length. I can't have a negative length. That doesn't even make sense. Okay, but when the vectors are going in opposite directions, one of them has to be negative in order to be able to mathematically compare what is happening. Now, does it have to always be to the left is negative? No. That is arbitrary. You could choose either way, but for our purposes, almost all the time we'll say right is positive and left is negative. We're doing one dimension. So what's the answer? 5 plus negative 5 is 0. All right? That is just how it works. Now, super easy. We're looking at numbers. We got 2 arrows. We got 0. Let's put it into an actual real person like scenario. This is easy? Good. I'm glad it's easy. If I have a desk, okay? So we'll just draw a little desk here. I know that's a lame desk. I got it. And I have 2 people, okay? They are pushing on the desk. All right? If both of them are pushing with a magnitude of 5 force, so there's some science words for us. If both of them are pushing with a force of 5, is that desk going to go anywhere? No, they're going to, okay? But if both of them are, like if this guy's pushing and this guy's pulling with a force of 5, what's going to happen to the desk? It's going to...
This is Greenwood. Can I have Logan Manchester to the office to leave, please?
Yes, ma'am. All right, so if our people are pushing or pulling on the desk in the same direction, that desk is going to move with a force of 10. Makes it easier to move a desk with 2 people. All right, that sounds easy. Let's look at some more. Well, that one seems kind of obvious, right? We have 5 plus 10 is 15. We're going in the same direction. Our vector increases just like our first example. Let's talk about this example just a little bit. And we'll continue to think about our people in our desk. So if we have a vector, and we'll continue to kind of think about it like force, of 5. So this guy is pushing on the desk with a force of 5. And this guy is pushing on the desk the opposite way. Needs to be a little bit bigger. With a force of 10. Because to the right is going to be positive, to the left is going to be negative. What is our answer? 5 plus negative 10 is negative 5, right? Super easy peasy. Which way does our arrow go? Look at our example. Yeah, it goes to the left. So when we look at this kind of problem, what is it really telling us? Which way is the desk going to move? To the left, right? So the resultant for this is going to be 5 to the left. Okay, so just because it has a negative number, remember our force or our arrow, our vector is still 5. It's still 5 units long. That's the magnitude, that's the size of it. But the direction is negative, so it tells us what our arrow goes to. So we might even make a note of that. Positive or negative indicates a direction. Okay? So we want to kind of keep that in our head, understand that when we're adding these vectors, we are going to get a direction. Now let's look at this last example real quick. We had pushing and pulling on the desk, but it doesn't always have to be left and right. So let's go ahead and put this example in our notebook. We could have 10 plus negative 5. Are we all right over there? what is that going to be? 10 plus negative 5 is 5. So the arrow is going to go up. That's right. It's always the larger number tells us the direction that we're going to end up with. So if we were to describe this vector, we would say 5 up, because we need a direction in order for it to be a vector. All right. Give me a thumbs up if this makes sense and you're like, yep, I got this. Good. That's good. Good. All right. So what are we going to do for our practice? I'm going to go ahead and pull the notes down a little bit, and we'll kind of leave that part if you want it. But if we look at the simulation that's embedded here, we're really only going to look at the first square. So when we look at explore these vectors, I'm going to click the values, and I'm going to click sum because I'm a little lazy and I want to see what the answer is without doing math. Okay? Sound good? All right. When I pull the vectors, I'm going to click on the vector and drag it over here. I'm going to click on another vector and drag it over here. Does it matter where we drag it? It does not matter one bit, but I do want you to kind of like, let's investigate that. Does it matter? I could put it right next to it. I could put it, but you need to look. This right here, the darker blue, is your sum. So this is like your resultant. This is your answer when you add the vectors together. So did you go to the Explore 1D? Did you click the values and the sum? Did you drag the vectors over? No, because the blue line was on the line. Okay, so yeah, it starts out, that's a good point. It starts out with your sum right on that x-axis, so that is a little confusing. I like to drag mine over here to the bottom so I can see it. It's up to you. So if I have these two vectors, 5 and 5, I have a resultant of 10. If I click on the arrow part of my vector and drag it, I can make my vector a different size, a different magnitude, and I still get my sum down here. Makes sense, right? All right, what if my vector goes the opposite way? Now notice, you guys need to take this in. The magnitude of the vector is still 4 units. But when I look at the math that I'm doing, it makes it a negative number to do the math with, because 4 plus 15 is 19. But negative 4 plus 15 is 11, and that's your resultant. So you almost always will go to the right is positive and to the left is negative, but you don't have to do it that way. But that gives us a resultant of 11 to the right. Okay. All right. So what do you got to do? I want for you to answer the following questions. So you might say, well, how am I going to answer these questions? I'm using this. Do I have to have a bunch of screenshots? No. I'm going to show you how to make it a little bit easier. Okay. First of all, what you want to do is go up to the top and you're going to hit start assignment, and it's going to give you the text entry. Okay, that rich text editor. I'm going to say, go ahead and copy your questions. Control copy. You're going to paste the questions into the text entry box, right? And then we're going to answer the questions. So let's do the first one. Show two vectors. Well, we already did the first one. Show two vectors with the same direction and different magnitudes. Type your math work to add vectors. What is the resultant magnitude and direction? All right, so for this answer, type my math work to add the vectors. I'm already given the math work up here. I'm going to pull my vectors back in. Okay, here's my sum. And it needed to have different magnitudes. So 5 and 10 is 15. So when I come down to my answer, I'm going to say 5 plus 10 equals 15. What is the resultant magnitude and direction? So then I need to answer that using those words. The resultant magnitude is 10 units, and the direction is to the right. Okay. So that's really all. You don't have to screenshot anything. There's your answer. If you want to be super official, you can highlight your answer in some color so I know what your answer is. Right? Then the second question. I'm not going to answer this one, but I'll show you how to do it. Show two vectors with a different direction and different magnitudes. Type your math work. So you're going to do a similar thing. Okay? You're going to come back up here. I'll go back to that here in a second. Come back up here, and we're just going to change the direction of one of the arrows. 5 and 19. In this case, okay, the program made the 5 negative. So proving that it doesn't always have to be to the right is positive, but you don't have to. Okay. You could go the other way like this. Make the 5. Okay. So then you're just going to type in those answers. So like in this case, 16 minus 3 is 13 in my to the right. So I want you to answer those questions, kind of play with the simulation, okay? And you probably wanted the answer again. Kind of play with the simulation. That's the kind of answer you'll have, just kind of a sentence for all 4 questions. All right. Does that sound like something we can do? Yeah? Okay. I'm going to stop recording.